Hello and welcome again to my channel. Today we are going to solve another lead code question. This time it is lead code number 11, container with most water, and it is marked medium. So let's first understand what's given in the description for the question. So it's given that it's written that we are given an integer array of height of length n. There are n vertical lines down such two endpoints this. Find two lines together that the x-axis form a container such that the container contains the most water. So let me just explain what the question is trying to say. Basically, I've copied this example here, right? Now these are bars whose height are given. Okay, so the input array looks like this: 1, then 8, then 6, 2, 5, 4, then 8 and 4, and actually it's a 3, I believe. 3 and 7, right? Let's just confirm it once. Yeah, 18625, 18625, 4837, 4837. That's correct. So these numbers represent the height of each of the bars, as I've said: 1, 8, 6. Okay, now our task is to find the maximum no, amount of water that can be contained between any two bars, right? For example, if we take these two bars, the amount of water would be this area, right? Because if it goes beyond this, it will overflow. So the maximum amount of water between these two bars is this. Between these two bars, the maximum amount of water would be this much. Now it's not like we can only take simultaneous bars, right? Consecutive bars, I mean. What we can do is this as well, like this, right? Now of course this amount of water is greater than this, so this will be our answer compared to this. But there might be some other answer which like there might be another amount of water which might be larger than this, right? So we need to find the maximum amount of water that can be contained between any two bars. Now we need a quantity to measure the water, which is the area. If you see the question, the function name is also written as max area. So the amount of water will be given to us by its area. Now how do you find area? We multiply length and breadth, right? Here this will be our length, and let's assume this will be our breadth, right? So that means this amount of water contained in this area will be how much? How much is this length? 6 minus 1, which is 5. If we count, we can ensure that 1, 2, 3, 4, 5, right? Let's not assume the area within contained by the bars, right? Let's ignore that. If we just assume the open area, like area between the bars, it will be 1, 2, 3, 4, and 5. So that means 6 minus 1. So we can write that down so we don't forget. Our breadth is j minus I, right? I am assuming the right side index to be j and the left index to be I. We'll see how this come in the code later, but just remember we are considering j to be on the right side and left to be on the I to be on the left side. Okay, now what is the height of the bar? The height of this bar is 8, and so is this bar, right? They are both of the same height, which is 8. So we can write that down also. Length equal to height of whatever I slash j. It can be either. Now how will we decide which one we take the height of? If you if you've noticed a pattern, or just a common observation is, what is the amount of water contained here? Of course it is 1 into 1. So the height we have considered here is of the smaller bar, not the larger bar, because if we consider the height of the larger bar, the water will come up here, which is not possible. It will overflow from this side, right? So in for measuring the amount of water, for taking the height, length, we'll always use the height of the smaller bar. Okay, now what will be the logic of solving this question? It's very simple. We'll take a greedy approach, right? Because we want to maximize the amount of water. But how are we going to maximize the amount of water? That is the question. So, as I said, the amount of water can be found by multiplying length and breadth, right? Length and breadth we are trying to maximize, right? We are trying to increase the length and we are trying to increase the breadth, which as a result increases the total amount of water or area, right? Now for any particular question, the breadth is fixed, or there is a maximum breadth which is fixed, right? For this particular question it is fixed to be 8. The maximum breadth there can be is 8, because 8 minus 0, right? So that means whatever we may try, right, this will be fixed, right? So what we should try doing is maximizing the length. Why? Because in any question there is no upper limit to the length, right? There cannot be infinite number of bars, but a bar can still have infinite height. Of course that's not possible. I'm just giving an example that a bar height can be significantly larger than the breadth, right? If you look at the constraints, height dot length is n and height of I is, so the breadth is kind of fixed, right? What we can do is we can maximize the breadth possible at the beginning itself, right? So in the beginning we'll take I to be this one, I starting from 0, and we'll take j starting from the last, right? As I told earlier that we'll consider j to be the right index and I to be the left index, right? So that means from the very beginning we have already maximized the possible breadth, right? This particular state will have the maximum breadth, and anything forward from there, because I will move left and j will move, sorry, I will move right and j will move left. That means as we move further in the question, the states that will encounter will have a breadth smaller than this, because this will shrink, right? This will keep on shrinking. So that means as we move on with the question, what we are actually trying to maximize is the length. So we are trying to find the bar which has a greater height, and we'll make decisions based on this intuition that we are trying to find a bar of greater height than we currently do, than we currently have, right? So that will be the logic of solving this question, right? So that means we'll store a variable called max amount, which will store the maximum amount that we can find, and it will be this variable that will be returned at the last, right? And also we'll on in every step we'll keep on calculating the amount using this formula, length into breadth, and we'll keep on checking will keep on changing the max amount if this current amount is larger than that, right? And that way we are going to solve this problem greedily, right? Again, the greedy logic, I repeat, is to find a increasing height, not breadth, because breadth will be maximum at the initial state of the question. So let's write code and you'll understand what I mean. Or we can do a simulation here. Let's see. So as you know, in the beginning I is this and j is here, right? So the amount of water will be this much, right? That means we have a max amount, right? So we'll say equal to, how much will be the max amount? 8 into 1, which is 8, right? Initially this will be the max amount. Next step, what do we do? How do you move on, right? So as I've already said, we are trying to maximize the height of the bar. At the moment, the height of jth index is 8, or no, 7, sorry. So this will be 7. This is 7, right? Okay. So height of the jth index is 7 and the height of the ith index is 1. So that means we'll not move j, we'll move I here, because we know I is smaller compared to j. That means we are trying to find a larger I and use it with j to get a bigger answer, right? So we'll move I. So that means I will reach here, right? I will do a strike through that I has moved on here. Next, we'll check the area for this. So the area for this is this much, not this much actually, sorry, because this has a lower height. This much, which is the height we are using of the jth index, which is 7 times 8 minus 1, 7, which is 49. So here it will be updated with 49. Now in this current state, I has a larger height than j. That means we'll move j towards left and j will move on to this bar, right? Again we'll find the area, which will be from this height. The area will be, what is the height of this bar? This is 3. Okay, this is 3. Then 3 into 7 minus 1, 6, which is 18. Will not update max amount because we have already found an answer which is greater than 18, 49. In the worst case, if we don't find any answer greater than 49, we'll return just 49, right? So this is not the answer. Again, I is larger, so we'll move j. J will come here. We'll find an answer, which would be this one, which is 8 into 5. 6 minus 1, 5. 8 into 5 is 40. No, we don't want that. So 49 remains. And we continue like this until it becomes like this or like this, in which case we break and we return the max amount. So let's write the code and it will become more clearer. Okay, as you can see, the answer was 49, this and this, right? So let's write the code. Let's first see the length of height, then we'll take 2 pointers I and j. I will start from 0 and j will start from the right, so n minus 1. Next we'll write a for loop or a while loop, I less than equal to j. Okay, we'll also take another variable, as I said, max amount, which let's say at the initial state be 0. Then we'll take an amount here which is also 0, but we'll change it. So we can get the breadth, right, using j minus I. J minus I gives a breadth, right? So we don't need to worry about the breadth. We need to find the height. How did we find the height? We took the height of the smaller bar of the two, right? So we need to check which one is smaller. So if height of I is smaller than height of j, in this case we'll take the height of I. So amount will be height of I times the breadth, which was j minus I. Else amount will be height of j times j minus I, length into breadth. Done. And after each step we'll just check the maximum amount, max amount comma amount, and we'll return max amount. But there is something else. We need to move the I and the j as well for each step. If you're in this step, we'll increase the I. If you're in this step, we'll decrease the j. Let's see if this works. It's a very easy question and this is working. Let's submit it. Even though it's marked medium, it's a quite easy question and it is accepted. So this was the question. This is the whole code. It's a very simple, easy code. The approach we took in this question is greedy approach and a two-pointer approach as well, because we have 2 pointers, right? So thank you for watching and I'll see you in the next one.